Hello friends, my name is Shivam from DevOps Schools and I will help you to enable your learning process in various technologies of DevOps, artificial intelligence, machine learning, big data and many more. This is our initiative to help you by sharing multiple tutorials and videos. And if you want any specific tutorials on any particular topic, then please do comment in the below comment section and I will help you with it. Also, please subscribe to our premium services on YouTube, which will give you access to more content and videos to enhance your knowledge about all these topics. Also, if you want me to help you with regards to the online trainings and classroom sessions by our qualified trainers, then please do write me at contact@devopsschool.com.
And when we do a clean, we go back here, then it deletes all the previously generated data. It makes our work area clean with respect to Gradle. All right, now let's say Gradle test. We want to test our application. Test is done. But what's the result of the test? How do I know? Well, let's go to the application folder and you can see build here. Let's go into the build. What do we see? We see two new folders. So previously we saw classes generated and TMP. Now we see reports and test results. So if you go to test results, our test results will be stored here. So in the XML format, the test results are stored and any outputs that were generated are stored here. I can open this XML file and see the test results, but as we all know, XMLs are very difficult to read. So what we get also is a report as well. Right? So you go to the report and the test report, and you open this report in the HTML format. So it generates a HTML report for us as well. Let's open it. Unfortunately, it opened on the other screen here, and you see this is the test report generated by TestNG. And you see that the package being tested is sample Java application, and this is the app test class which got executed, and this is the actual test, and it has passed. If we want, we can break this test as well. So let's go ahead and go to our application, go to source and main, and change the functionality of our application here. So if I put it in VS Code, and here instead of printing something, I'll just say return null. Right now my test will fail because test expects a text output, but here I'm returning null. So if I run my test, it will fail. Let's test that quickly. Build fail with an exception. App test. There are failing tests, right? So you can see there are failing tests. So now let's refresh our report here, and you can see 0% successful, one test has failed, this has failed, and we can see app should have a greeting, something has gone wrong here, right? So this is how you can run your various build steps and generate or create your simple Java application. Make sense? Any questions on this? No questions? All right. Okay, so now let's come back to our build.gradle. And you can see here, there is a dependency here. Now this dependency is defined as test implementation. So for testing, we have this dependency on JUnit, right? Now how this dependency will be resolved? So first of all, we say that, okay, resolve this dependency from this repository. Yeah, we can also specify any other repository, for example, JCenter, which is hosted on Bintray, right? So on JCenter, they can resolve the dependency, or any other dependency there, or dependency or repository there. IV repository also can resolve this. Okay, so what Gradle is going to do is going to contact this Maven Central repository and find out the organization JUnit, and in that a module JUnit, and then the version. Okay, you can also write it for more clarity. You can write it like this. Maybe I'll use in VS Code itself. Build.gradle. Yeah. So if you comment this out, you can write this as something like this for more clarity. Yeah. Group as JUnit, right? Name as JUnit, and then version, this particular version. So instead of writing everything together, if you want to bring in some clarity, you can say group, from this group, find out this plugin and this version, right? And this will also resolve. So you can specify the plugins or the dependencies that you want to resolve in the dependencies section. Now, what happens to this dependency section? First thing is that Gradle is going to try to get this dependency from its local folder. So if I open my whiteboard here, so Gradle will evaluate your build.gradle and it will find a repository or a dependency, right? So first thing that it is going to do is it is going to check local folder. And obviously, when we run the project for the first time, the repository will be not found. So if not found, then if the repository is, or if the dependency is not found in the local folder, then contact the remote repository. For example, Maven Central. And once the dependency is found there, store it in the local repository, local folder, and then use it in your build. Okay. Next time when this dependency is required, Gradle will check in the local folder and it will find the repository or the dependency there, and it will immediately use it. So for the next time onwards, it will not talk to the remote repository. Okay. So where is the local folder? Where is all the dependencies stored? Let's go to this Java application and let's explore this .gradle folder. Right? If I go to .gradle, what do I see? We have 711, right? And everything required Gradle.711 is here. Right? And if we go to the Gradle folder here, okay, this is strange. Actually, the repositories should be here in the .gradle. Is interesting. Okay, looks like something has changed in 711 version. I don't see it here. Let's check it in our home, in my home directory. .gradle. All right, looks like everything is coming to here. Let's look for JUnit in this folder. Yep, so we find JUnit. Just 1 second. Yeah. Open folder location. Okay, so in .gradle and cache, right? If you go to .gradle and go to caches, you will see modules, right? And files maybe, and then you can see all the modules or all the dependencies that are downloaded. So it stores in the home directory, home drive, and /gradle, right? So if you go to JUnit, and the various version required. Okay, so this is how you can set up, or you can set or Gradle actually caches all the dependencies to the local folder, and whenever the project requires it, it just takes it. Now if I delete this JUnit dependencies, so if I go here inside and I can see, you know, in the pom.xml downloaded and the jar file downloaded, if I just delete them and if I run Gradle test again, I say Gradle test. If I run Gradle test, Gradle is going to automatically cache this again. So we'll just watch it here. You can see it also again downloaded it. Right? So this is how the dependencies are managed as local and remote repositories. Okay. Any questions on how the dependencies are managed? Okay, no questions. So is it clear or is it getting confusing here? I need some feedback.
So far, it's clear for me.
Okay, good to hear. All right. So this is the basic gist. Right? This is the basic gist. Then we can also write some complicated tasks ourselves, right? So if we go back to our simple application, the first project, now this project has the complete Java application, right? So if we go back to the other project, which we created, Gradle and first project. Yeah. So in the first project, if you open build.gradle again, here we created one task, right? So now let's write a bit more kind of a task relationship. For example, let's define task relationships here. Okay, so we will not work with the Java application. We'll just work with the basic application and then see how we can write some more tasks. So this is a basic task. You will see the task, and when you execute it, it will print the hello world line. Let's create another task. So let's say in the hello task, we will print only hello, right? And let's register another task and let's call it as world, right? And yep, and here I will say do last. What will I do? I say println world, right? Now I have two tasks here. Now it will be nice if I can say that if somebody runs hello task, it will print hello, right? But then if somebody runs world task, well, it should actually first print hello and then print world. So I can define a dependency here, right? So I can say this task depends on hmm, tasks dot hello. So my world task depends on tasks dot hello, right? This is how I can define some relationship in my tasks. Let's save this and let's move to first project. And here I will say Gradle tasks. I will list down the tasks. Yeah, so by default, when you just say Gradle tasks, it will list down the system tasks here, right? When I say Gradle task hyphen hyphen all, it lists down my custom tasks also here. Okay. Now, if I say Gradle hello, it should print hello as expected. Okay, it printed hello, right? Now, if I say Gradle world, what it did, it printed hello and then it printed world. Right, this output is a bit jumbled here. I don't know why it's a bit jumbled. Maybe now let's run it and see how it works. So now you can see first hello is printed and then world is printed. So when you run world, it will mandatory run hello first because that's a dependent task. So if you run a test, it will mandatory run a compilation first, right? If you run a deploy, it will manually run compilation and package, right, in the Java project. So this is how you can define the relationships between the tasks. Yeah, you can also write complicated logic in your task definition. So for example, you can say let's say this, we can create some variables. For example, let's create a variable here. Let's create a string variable and let's call it as greeting, and the variable will have world, right? And now let's print the greeting, right? Let's print the greeting, but let's convert it to uppercase. So we can write all programmatical expressions in our task definitions. Right, so this is going to print the greeting statement, but in uppercase. Yeah, let's see that. What happened? Cannot find method dollar. Okay, let's check this out. Yeah, I had to, I think, put it in quotes. Yeah, now you can see world is in caps. So your build.gradle is not just a static file like pom.xml is just XML. You cannot do much there. Here you can specify the complete behavior of your project with this. Yeah. So that's how you can write some complicated tasks or some intelligent tasks where you can put this. Now Groovy supports every programmatical syntax. For example, if else, you can define if and else. You can define loops, you can define string interpolation like we did, string operations, mathematical operations. So everything can be defined here, and that can be used for defining um, complicated project settings. Okay, so this is what I wanted to share with you for Gradle today. Now, Gradle has excellent documentation of their own, right? So if you go to Gradle and go to their documentation, they have excellent documentation. Now, if you have some time, you can go to, why we use Gradle and, what are the advantages of Gradle, how do we install it, how do we upgrade it, you can see here. And yeah, how do we customize it? And then you have some examples. For example, how do we build Java application and things like that. Then dependencies and repositories, you can think or learn about it later as well. Now, as a DevOps engineer, right, and I think that's the training that you are taking. As a DevOps engineer, you will not mm, work so much in detail with Maven or with Gradle, right? Your main job is to enable the development team to perform all their tasks, especially relating to operations automatically, right? This is something that development team should take care of. Okay, so as a DevOps engineer, you should understand Gradle, you should understand Maven, how it works, what are the technologies behind it. If somebody gives you a task to, figure out something that is not working in Gradle, then you should be able to do that, at least understand. But you are not supposed to be experts there, right? So make yourself comfortable with Gradle, but do not invest so much time that you don't learn the actual DevOps tools like Docker or Jenkins. Okay, now there was one question on how we can set up build cache, right? So if I say Gradle world and build cache here, okay, maybe not here, but let's go and go to simple Java application. And here, let's do a build cache. Let's see if we get something. Let's also remove the test failure. Okay, so what happens is right now I don't see it. Some behavior has been changed with 711. So I will need to do some debugging here. But what happens is when you do a build cache, Gradle will automatically upload the build cache to its own website, which is Gradle itself. And you get a URL here that your cache is stored at this location. And then you can go and browse the cache by yourself, or you can set it up with build cache to the other builds and they will use that cache, right? But unfortunately 7.1 I don't see it here. Yeah, using build cache. Let's see. Run with build cache on the command line. Okay. Okay, so it creates local cache and remote cache, right? So local cache is stored in your local .gradle home directory .gradle folder, and the remote cache, if you want to share the cache between multiple users across the organization, that's when the build is stored on a remote server, right? So if I browse, for example, C users DE and Gradle here, so whatever cache is here, you have your build cache, right? So when I executed my build, let's delete this cache here. When I executed my build with cache, it will create a build cache here. You should see pretty soon. You can see a build cache is created. Yeah, and this is the cache, and this is what it stores. Wow, nothing is stored here, so I think there's nothing important. But yeah, it will store here everything. Okay, and then when your next time build happens or your data is generated, your binary is generated, that's when you get your cache updated. And cache can also be reused then with the same project. So all the subsequent runs, if I say Gradle build cache run, it will reuse whatever was generated in the previous build and then get something for us. Yeah, so this is what cache does: create reusable artifacts. I think this is a very small project, so the cache is not too much here. Yeah, but yeah, you get the idea how it works. Okay, so that's all from me. Any questions?
Amit, if there is a requirement to toggle between different version of Gradle for different project, so in the property I can put all the version and comment out,
Yes.
use the wrapper. That's a solution, right?
Yes, so you can go to the Gradle properties, right? So you can go to
In
the
that case, I will write the Gradle U or Gradle wrapper command instead of Gradle.
Gradle W. Yes, so you will use Gradle wrapper. Yes. So here you can say, I want to use 6.1.1 or whatever version you want to use. Yeah, and then it will download. Gradle W will download this, and then it will use Gradle W here. So if I go up and go to first project, Gradle W, and then I can say hello.
Mm-hmm.
Right, so now it will download this specific version and use this. So not the system install Gradle.
So for this one, I do not have to set the home page and export the path.
Nothing.
Okay.
But to initialize this project, you need to have a machine with Gradle, right? So somewhere, yeah. But then if you want to distribute it to others or other team members, or you want to run it as part of your CI, then you don't need to actually install Gradle anywhere. You can use Gradle W.
Okay. Yeah. Thanks, Amit.
Any more questions before we wrap up for today?
Amit, I have one doubt.
Mm-hmm.
In the properties, we have used the Maven Central, right?
Yes.
Gradle is having any own central repository, or it's depending on the Maven only?
So you can set up your own repositories also, right? There are ways to set up your own repositories like Artifactory. I'm not sure if you have heard of Artifactory.
Yes, yeah,
Um,
I had heard Artifactory.
yeah, so Artifactory is a binary management and a repository management solution. So you can create your own Maven repository on Artifactory in your organization
Okay. Yeah.
and use that to resolve your dependencies.
Okay. Okay. Yeah. Okay, Amit. Thank you.
Yeah. Okay. So before we disconnect, I see that questions are exhausted now. Do you have any feedback to share? How was the class? Was it good? Interactive enough? I know we can talk a lot about Gradle, a lot, but yeah, in 2 hours, this is what I felt we should cover.
Yes, it was a good session. Like with the hands-on, at least we know what we are doing. We also encounter few times this build failure, and yes, at least we gotten hold how to start without worrying. Then we can keep on adding our library plugins or tasks accordingly.
Exactly.
So it
Exactly.
was a good session. At least for beginner, I know where to start. Then keep on adding my stuffs as required.
Thank you for the feedback, Hasmitra.
I like the session too. As a beginner, I got the basics for Gradle, which I didn't know before, so I liked it.
Thank you, Raksha. Highly appreciate it.
It was interesting for me as well.
Thanks for watching. Want to study further? Join our training programs today.